of old men saying things they think is maybe the worst slot. So Peter at least gets to finish it off. Everyone will perk up again. So to keep everyone awake, I have decided to try to do 100 years of history in 25 minutes. And it was working, I thought. Did it go? Good. Okay, good. Okay, so as a couple other people said, you start the first day saying what the field is, and it's often defined as the applied study of imperfect competition. Although it's often followed by the fact that almost all markets are imperfectly competitive, and of course, perfect competition is the limit of imperfect competition. So I'm feeling imperialistic, and I'm going to say that IO is the study of markets. And in practice, we study markets in partial equilibrium. And a lot of that has to do with the attention to detail. I don't think it's necessary, but it has a lot to do with the attention to detail that several people have talked about, that it's hard to model all markets at once. So the word partial places us in contrast to trade or macro or other fields that are define themselves in many ways as being general equilibrium. And the word equilibrium puts us in some recent decades in contrast with, say, labor, public development, and other fields who are less interested in equilibrium, although it's not clear that that's correct. Okay, so I'm going to focus on equilibrium counterfactuals, not because that's the only thing that IO economists do, or necessarily even the best thing that IO economists do. Applied theory is really important, studies of institutions, testing theories, which sometimes looks like equilibrium estimation and other times is looking at more qualitative things. We do a lot of work doesn't get to the full equilibrium, that looks just at demand or just at production or whatever. So that's all very interesting. But today I'm going to focus on empirical work that aims for an equilibrium counterfactual. And in many cases, this will be a counterfactual policy analysis, although it could be some counterfactual aimed at illustrating a mechanism or something like that, right? And I'd say this is kind of one thick slice of the field. Okay, so I want to make an argument. So here's the argument. I'll say it's a provocation, although I'm a little nervous it won't be very provoking in this room, maybe just elsewhere, which is that IO is the field that has carried forward what I would argue is a century-old promise here, which is that we could do the kind of counterfactuals that we teach the undergraduates are a core part of economic thinking, that the importance of this work goes beyond sort of our home questions about firms and competition, and that this leads to the growing trend, especially among young scholars, of work that we label IO+. And at the end, I want to come back to what that means for the future of our field, right? Are we dissolving? Are we expanding? What is it that's happening? And if you're already convinced, we could think of this maybe as a frame for talking to those in adjacent fields. But not everyone may be convinced even in the room. Okay, so the promise of an empirical equilibrium counterfactual goes way back, right? And so you think of Marshallian counterfactuals in Marshall's original introductory textbook, and I teach undergraduate, I teach the freshmen, we teach them again and again. Here's a model, here's a counterfactual, here's the elasticity that matters, here's how we evaluate a carbon tax or whatever. And in the histories of econometrics, the person who gets the credit for doing this or presenting the framework in an empirical context first in a credible way is in P.G. Wright's 1928 book, which is a very long, boring book. It's worthy. It's on the tariff on animal and vegetable oils. And, chapter 1 is what are the animal oils, and chapter 2 is what are the vegetable oils, and then what are the tariffs on animal and vegetable oils. And then he gets to the appendix and he says, okay, let's get serious. What if we really wanted to do this? What would we do? And in Appendix B, he derives IV estimators, correctly identifies the exclusion restrictions in supply and demand that correspond to those estimators, writes down the counterfactual, uses the model to define the counterfactual, collects the data, and estimates at least the domestic elasticities with, I think, a super convincing shifter of supply, a less convincing shifters of demand, a problem that was not rectified until a 2013 AER paper that begins, we extend the method of P.G. Wright, 1928. Right? This story has been told again and again because this whole thing just appears out of somewhere. It appears. It's told in many histories of econometrics. Goldberger wrote about it. Jim Stock wrote about it. The big histories of structural econometrics wrote about it. Angerst and Inman's write about it. There's a new paper by Arbring, Zurkov, and Fernandez-Val. So if you read Angerst and Inman's, what they say is that Wright's paper is good because it introduces IVs. IVs are like natural experiments. We need natural experiments. This was a very important paper. But as a side comment, maybe unsurprisingly, they say that while his demand instrument is good, more complex simultaneous systems are often identified by implausible and unexamined choices. And I want to take that criticism seriously. I don't want to say, oh, that's not us, that's the other people, right? Maybe, I mean, I think it's a serious question. Is that us, right? And to what degree is it us? Now, Arbring, Chernyshov, and Fernandez-Val, I think, present the paper much more in the spirit of the original paper, which is that in an equilibrium context, at least, maybe in other contexts as well, we need a model to define, identify, and estimate a policy counterfactual. Some pretty famous people have made the mistake of thinking you need a natural experiment in price and have looked for a natural experiment in the market price to identify demand. But we teach the undergraduates that if you randomly set the market price, you will end up with excess supply or excess demand, and it will not identify either one. Now you think about the model and you realize what the marketing people would realize immediately, right? Which is you need to separate the price to the consumer from the price to the producer, and then you could randomize. Or look for a natural experiment, which is why you need two instruments, right? The model defines the counterfactual. It doesn't just define the estimation method. It tells us by the natural exclusion restrictions what are the potential categories of instruments. And by the way, he estimates the model parameters with real sensitivity to the market detail. He thinks about, like, he says, okay, butter and milk are substitutes on the production side. We should worry about that. And here's his counterfactual. The same thing we would do for an undergraduate. He's looking for delta P. It's kind of like the delta tau that we were just introduced to by the Trump administration. Only he notes that it depends on four elasticities. Elasticities of supply and demand of domestic and foreign production. The notation has changed. I think the O's are outputs. So we've got four elasticities to be estimated in his simple partial equilibrium framework. There's no terms of trade here or anything like that. And let me just make a couple comments. One is, this is, as I say, the kind of counterfactual that we teach the undergraduates, and that Jim Heckman has noticed this connection between the Marshallian counterfactual and the empirical counterfactual. Both are ceteris paribus, right? So we want to hold things fixed, maybe even the unobservables in this particular market if we want to do it for one market, and we want to run the counterfactual. Just a couple other side points. One of the reasons we haven't been able to adopt the late framework as much, even though it's a very general framework, and I think one has to learn a ton from it, is that these elasticities would be estimated from different combinations of instruments. They would be different lates, right? And then you're getting different incommensurate lates, and you're taking a nonlinear combination of them. So even if every elasticity was a proper late all on its own, the conditions under which delta P would be, I think, are not so obvious, and that's what has slowed this. And the other thing I'd just like to point out, this is the first proposed equilibrium empirical counterfactual, and it depends on four sufficient statistics, right? So that's not a different approach, actually. Okay, so that's great. So it's 1928. We can already do a Marshallian counterfactual, and we can now introduce imperfect competition and other things. Okay, so the discouraging thing gets to your point about how long it takes to do stuff. Wright became famous later, but this had absolutely no immediate impact, right, on the profession. Maybe it was buried in the back of this book, and P.G. Wright was a sometimes Harvard lecturer. But nonetheless, over the next couple decades, maybe 3 decades, 4 decades, the Coles Commission and other reinvented many of these ideas, and they extended them into general notions of identification and this beautiful framework of linear simultaneous equations model, which was the central gem of econometric theory. I think if you took econometrics in the late 60s, early 70s and stuff, this would be a big thing this would be like a central gem of that. Okay, so once again, we have solved the problem, right? Now we know how to do this. Okay, I think empirically, sort of, that's not true. These models were largely used in empirical Keynesian macro, but those were attacked as having arbitrary exclusion restrictions, unexamined exclusion restrictions, just like the Angerst-Inman criticism, and by the idea that the models themselves were just bad. Lucas said they weren't structural. I think his actual criticism was they were just bad. Maybe they were structural, but the counterfactuals that came out of them would be bad because they were bad. They didn't have expected inflation and stuff in them. And I have not found, maybe there is some large empirical applied microliterature that grew out of this linear simultaneous equations methods, particularly, at least outside of IO. By the way, most econometrics textbooks today barely mention this. And indeed, I couldn't find one that made anything but a passing reference to any kind of market equilibrium estimation. They use the supply and demand model to say, oh, this, for example, you sometimes need an instrument, and then they move into an instrument for something else. They never work out an equilibrium counterfactual. Okay, so here's one linear simultaneous equations paper that was made famous by Tim, which is Jim Rossi's thesis, mid-late 1960s thesis at Minnesota. Like Wright, where does this thing come from? This modifies the perfectly competitive framework, uses the first order condition to study the newspaper industry. He assumes monopolistic competition. So rather than the P equals MC first order condition of perfect competition, he adds the markup term for the monopolistically competitive firm. It's a two-sided platform with ads and subscriptions implying multiple endogenous variables. He never mentions an instrument, but he puts it in the linear simultaneous equations framework and carefully tracks the exclusion restrictions. So the instruments are there. They're just done in the language of included and excluded variables. Okay, he has some problems. It's 1970. The computers aren't that great yet. He has some nonlinear constraints. It reads a bit like a lab report. You could publish your lab report in Econometrica in 1970. This worked, this didn't, this parameter makes sense, that one doesn't. So, okay, I would once again say, okay, but fine, now we're back on track. And it's in the context of IO. And maybe it's in the context of IO because one of the reasons maybe not too many people wrote the supply and demand paper was that most markets are imperfectly competitive, which may be a big reason there was never a large sort of homogeneous goods supply and demand network. The ag people have no excuse, but it just didn't follow up. Okay, so game theory comes. We've talked about this before. Tim has talked about this before. And so we get this great growth of empirical IO oligopoly papers. Now, by the way, a lot of people wrote down the theory, got all the way to the end of the theory section, said we now add disturbances to each equation and estimate the model. Sometimes it's even hard to see what they mean by that. I think sometimes it's OLS. I think it's often maximum likelihood. They just assumed that they were normally distributed. So somehow, despite the other papers, despite the whole simultaneous equations thing, people have P's and Q's and functions of them, and they're running everywhere, okay? And there's no notion of an instrument, an exclusion restriction, or anything in many of these papers. Okay, very much present company accepted, okay? For real. Read Rob's work, right? Explicit unobservable separate shifters of demand and markup, which you would say, well, come on, it's not that common. And I just went back and reread this recently. Brezhnevan's paper on the new empirical IO, where he consolidates a lot of this work. And again, if you read that work, it's very explicit about identification, about the use of the model to define tests for competition and that sort of thing. And explicitly talks about the advantages of identification in this context, that you can think about what's excluded and does this in the context of a fairly general oligopoly model, right? So by this point, actually, I would say that even though the focus of a lot of this work is on these literal competition, testing competition things, the pieces are in place now to do this equilibrium counterfactual, right? This many years after 1928. I think the important things here are that we have now incorporated imperfect competition so that the models are much more realistic. And again, there's the bit about data and computers and things, so that all of this is much more possible. So how do you think about BLP in this context? In some sense, like Tim's auto paper, it's an elaborated supply and demand model. And it's building on multiple earlier literatures. I think Rob will back me up that the way I remember it is that the referee said, okay, one thing about this paper is there's nothing new in it, right? We knew about discrete choice, we knew about instruments, we knew about this, blah, blah, blah. Yeah, Rob says, yep, that's what they said, which by the way is fine. Random coefficient logit, that's not new, right? And all of that's right. You can go through all the things, right? And indeed, if you think about it, right, this stuff didn't spring out of nowhere. There were all these earlier attempts. and you guys had quant, right? And you had McFadden, right? And you had Grillicus thinking deeply about production and everything, right? And now I'm way luckier because I had Ariel and John at Wisconsin and the ability to read Porter and Bresnahan. So I'm not hard to explain. But these guys are hard to explain, but it's because all of this work had in fact been done before, right? And now it's really coming together. Okay, so on the other hand, BLP is a little more complicated than Wright. How do you get those random coefficients in the random coefficient logit that's putting us in the product space that Tim was talking about? And again, I want to take that seriously, and not just in the context of demand, although obviously that's easy for me to talk about, but in the context of dynamics and entry games and auctions and search and market design, right? In all of these cases, we have questions about the model and about equilibria. And we should take seriously this idea that as the models get more complex, we should think about, are they credible or are they not credible? And I think this perceived issue is a big problem for the spread of IO style work outside of explicitly trained IO students, outside of our own students, really directly, right? And this, I don't kind of mind being in the messy middle, but I think we were sort of in the messy middle between the credibility revolution with things that were perceived to be very clear identification strategies, but not typically based on economics, typically based on statistical argumentation. And on the other hand, people who are very much our allies in counterfactuals, in trade and macro, and they just solve these problems by just making assumptions that make the problems go away. You just estimate a Cobb Douglas off the cost share, right? You guys do a lot of work to get a production function, right? I don't know why. Okay, so, I think we have to take this seriously. What would make our style of work credible, right? More credible, right? It's always going to be a model. And probably we're always going to have to make more assumptions than if we're just trying to get the effect of an X that's already in the data. Because an equilibrium counterfactual is often something that's about something we've never seen, right? Think about that trade thing or just an excise tax or a carbon tax. It's an astonishing statement. You're going to say, I have never seen a tariff on this good, and I will tell you what delta P is. Right? So it's going to take something to get there, right? And in the end, it may not be as credible as looking afterwards, but someone's making a decision. Someone's calculating the delta tau, right? And is it Peter Navarro or is it, I don't know, is there an IV in there somewhere? That's the actual policy question. Okay, so I want to quickly work through a familiar example and discuss, it's my example, and discuss why there's some natural skepticism and how we might work to address it. And the thing I want to do is, we all know this in this room, a diversion ratio, right? So if you raise the price of good J, how many go to choice K, right? Of that as a fraction, how many go to choice K? This comes up, we discuss it because there are merger counterfactuals. I don't have time to go through all these things, but what if you wanted to look at job choice? Do you go to similar jobs, similar occupations? Where do you go? That's a diversion ratio. We have this voting cost paper. You could think of it as selection. You go from not voting to voting for the Democrat or the Republican. That's a diversion ratio. The multilateral trade war, not just one partner, many partners, diversion ratios, land use. I love this paper at the bottom because that doesn't look anything like IO. It's a judge fixed effect model with 2 dimensions of preference. It turns out the math is exactly the same, right? If you make the jail term worse, do you move people from jail to conviction or jail to acquit? It's the diversion ratio. Okay, a lot of choices. Some of these cases, there are 3. That's maybe not too bad. Autos, there are hundreds. So one thing we're going to have to cope with is functional form, right? We can't get a separate IV estimate of all the own and cross price elasticities across all the choices. We're just not going to do that. So we're going to use some functional form restrictions. And furthermore, when we run across markets, there aren't that many. We're not doing real non-parametrics probably in most markets. But on the other hand, we have this credibility issue. If our functional form determines the answer, then perhaps people should pay no attention to counterfactuals. And that's a trade-off that involves a lot of things: data availability, the question at hand, and credibility. And there's a similar trade-off about where we put our modeling focus. Do we have a reduced form profit function in the entry model, because that's not really our question at hand? Or do we carefully model the variable profit function, right? Maybe from other data. May depend on your question at hand. Okay, so we know this, right? It's possible, and people are aware of this, that our functional form could be determining the answer. It's actually possible, right? Think of the IA property of the logit. All the cross-price elasticities of good K with respect to good J are equal. The CES in the trade and macro literature is a logit in revenue shares. So when they predict trade outcomes across companies, across countries, in many cases they are just reproducing the mathematical properties of the CES, nothing else. So the concern, of course, is that we know that, but that other fields might think we're sort of pulling a logit elsewhere, right? And that maybe even we don't know that we pulled a logit, right? So what do we want to do? We want at least some kind of flexibility. We want to add substitution parameters, random coefficients, a probit covariance matrix, maybe if there are only 3 choices, things like that, that let the diversion ratio vary in some flexible way. And again, to drive it home, let's give a non-identification result. Let's say we've only got one choice context, one model, and it's a random, it's a classic discrete choice model. But I'm going to let myself freely choose the distribution of epsilon. They might be correlated, they might be uncorrelated, normals, logits, I don't care, whatever. There's just epsilons there, they can be anything. But by the classic inversion that we all know, right, I can back out mean utilities that explain any data. It's like the non-identification result you talked about. So in one choice context, we can perfectly explain the data with any distribution of epsilon, but every different distribution of epsilon is an entirely different substitution pattern. So that's a problem. So what we learned, for example, is the necessity of choice set variation. To make something credible, we better have some choice set variation. It shouldn't be surprising. We're trying to see how people substitute. If you don't present them with 2 choices, how are you going to learn how they're going to substitute, right? It's not deep in some sense. And again, that's not just true for the logit. That's true for CES. It's true for a lot of other really inflexible structures. Okay. Okay, there's another talk I could have given, which is this slide, right? I've just given that talk a lot recently. One part of the answer for me is to think carefully about identification, right? And to try to convince the outside world that we've thought carefully about identification, that we have answers because they're pretty good answers, right? Doesn't mean they can't be improved. So from pure market level data, we know that we need some choice set variation. And we typically are also going to need some restriction on the way that choice set variation affects the deltas. Some kind of exclusion restrictions in that system. For example, things that causes choice set variation, which we can think of as instruments, are exogenous changes in the choice characteristics that I guess Aviv or somebody labeled the VLPIVs. And or cost or markup shifters. And what Phil and I have shown is that in highly unrestricted cases, you may need both. You may need fairly rich variation in both. But as we make stronger restrictions, sometimes you can get by with one or the other or some combination of both. With microdata, which again is going to take some panel data style restrictions, many consumers across multiple choice sets, effectively, the change in those mean utilities, the deltas, can provide a source of choice set variation that actually identifies substitution patterns. Okay, now there's a lot of math to do to show you can learn the deltas and the choice set variation at the same time. I think it's not so obvious. That's why it takes a paper, right? But that's what we say. And of course, you could have great other kinds of data like second choice data, although that's not directly informative about price substitution. It's certainly super, super informative about substitution patterns more generally. Okay, so I'm stubborn and I need co-authors, but anyway, there are a bunch of papers. What about credibility in other IO models? It's all the same thing, I think, right? I just did this one example, right? In entry models, right from the beginning, Peter and Tim are thinking about how variation of market size can help identify parameters involving fixed costs, right? Ely Tamer's work does a lot of this. In production function estimation, in some sense, Zvi Grilicus puts down a challenge. Ollie Pecos, one way to think of it, oil focused on the empirical output, which people forget about. It's really good. But the theory part is like it's an identification paper, right? That part is about, is there something credible we can do here in a world where we've written down a function, Q is a function of L and K. I have 3 variables and they're all endogenous, right? Tough problem. Can we do that more credibly? To what degree do we use proxies, timings, instruments, other restrictions? in dynamic models. How do we learn? How do we learn about discount rates? I've been interested with Giovanni recently. How do we relax the assumption of independent error? Is a question that goes all the way back to Heckman and Singer. Only that's not advancing. My clock is running down. Not advancing. There we go. Just a little delay. Okay, I'm going to argue, again, maybe as provocation, that it is our collective success at that that has attracted all these other fields to us. Right? Just like you say there was a game theory revolution or something, if you went back to the 1980s, an urban economics textbook would be a theory textbook. It would be theory and stylized fact. If you, right, and a public economics textbook would be about optimal taxation and elasticities, and it would be a theory textbook. And the questions would be, what if we change the tax system? What if we build a different transportation network? They were counterfactual questions posed in a well-articulated theory, and that's what those fields were. I think it's true. Well, I studied a lot of urban when I was an undergraduate, and I don't know, there wasn't much empirical work going on when I started. And then people like Ed Glaser showed up and they're doing empirical work. It wasn't structural work. My understanding is he now comes to the IO seminar, right? So that's the evolution of applied microeconomics. Kind of a market test, right? I don't know. Maybe we're not the best, but we're gaining market share. It's be a high delta, I'm thinking. Look, yeah, I'm just going to finish with this, which is I've noticed there's like this IO plus job market candidate outline, which I actually love. And it goes like this: interesting question, genuinely interesting question. Okay, now this was not in the Coles framework, but this is excellent, right? Rich data description, often with an IV or a diff and diff or something, display of the variation in the data, right? That convinces you there's something going on here and also starts to build the identification argument, right, from these sources of variation. Okay, then they say, note though, that this does not answer the counterfactual question of interest, and that will require a model. You can just fill in the blanks, right? And then they're going to show you the model, they're going to talk about identification, they're going to give you the estimates and the policy counterfactuals. I say that really is the classic Coles structural modeling outline, except that 2 is much better. Right? 2 is just way better, which is where we're learning, right, from our colleagues elsewhere. Okay, so if we do at some point look back at this era of IO in retrospect as something that ended, we were joking this morning. Before Gunther talked, we were a little worried about this as our funeral rather than a celebration. One possibility is it's because the field boundaries continue to collapse, right? I mean, the labor public boundary collapsed into something called labor public, right? And a lot of schools had a labor public seminar. I think, once again, the field boundaries are collapsing a little bit, and it raises interesting, I think, kind of fun questions about the future of IO, right? Do we go back to a smaller set of questions about competition? Can we re-specialize in competition because everybody knows the tools and they can just be public? I think sociologically what's happening is that at many schools, most of the graduate students, at least almost all the graduate students who want to do empirical work, take the IO class as a methods class, right? Because of the success of these methods, right? So I don't think the names of the fields are important, and what actually happens is up to the young people in the audience. When Arl and I were both younger, by the same number of years, we used to have a conversation that went along the lines of, there are different kinds of talks. There's the old man talk, who talks about the history of the field and where we ought to go, right? And then there are the people who define the field by writing the papers, right? So that's up to you guys, actually. I'm done. Exactly. Put down a marker. We can place bets.
Yeah. Young guy.
Yeah, a very interesting talk, Steve. I have a question, which is, when you talk about IO plus and how the papers look like, IO paper would look like, is it any different or is it the same? supposed to argue so we can.
Is it just the public labor boundaries that are going to collapse? When is macro coming?
Well, I mentioned that. I think trade is closer, right? Trade, I mean, spatial is already collapsing, right? So if that field, trade is becoming more spatial, right? I often don't know if people self-define as spatial or IO, right? I have to go check their website sometimes. And yeah, maybe someday macro. Wow, isn't that discouraging? Yeah. I don't know. My impression is that the structural linear model stuff was taught as too much of a game, in a way. You know, you had to put in some exclusion restrictions somewhere, right? And I think it was just not. I mean, to some degree, Wright was just ahead of his time, but the techniques were developed a decade or two later, more generally. And why that didn't stick, I don't know. But it's because of that Angry-Simbish criticism that the exclusion restrictions struck people as being arbitrary and unexamined, right? And that's what I'm saying. We have to avoid that to the degree that we can. Yeah.
Do you have any concern about all papers looking the same?
I don't know. It's like a product space and it's close to me. So. No, all papers should not look the same. We were just talking earlier about how there ought to be more applied theory papers, right? There ought to be more good applied theory papers, right? In IO talks and stuff like that. Qualitative testing of theory, okay, there aren't enough examples, but we heard about a few of them, and that stuff is beautiful often. It's like gorgeous work, right? So I wouldn't mind seeing way more of that, right? So, you know, I like it, but no, it's probably not healthy.